Hi everyone, this is Mrs. GA, and today we're going to talk about perpendicular lines. So remember that perpendicular lines are lines that intersect at a 90-degree angle or a right angle, which remember is 90 degrees. So that means a perpendicular bisector, it does two things. Well, it has two properties. It is perpendicular and it bisects. So it is a line that intersects a segment at a right angle, the perpendicular part, and cuts the segment into two equal parts. And remember, that's what a bisector does. A bisector cuts a segment perfectly in half. So the perpendicular bisector theorem states that if a point is on a perpendicular bisector of a segment, then it is equidistant from the endpoint. So let's look at this picture. First, we need to make sure this first part is true. If a point is on the perpendicular bisector. So to show this, we have to draw the little 90-degree angle, showing it's perpendicular, and we have to show that these are congruent, meaning it bisects it. Well, if that's true, then it says, then it is equidistant from the endpoints of the segment. So here's the point, and here's the endpoints of the segment. So that means that these two distances are equal. So that's the perpendicular bisector theorem. So this first example says, use the diagram shown, BD is perpendicular to AC, so we see this, and it's a bisector, so we see these two congruent parts. Suppose ED is 60 and DA is 65, find DC. Well, the fact that they told us it's a perpendicular bisector means that this segment is congruent to this segment, and they told us that this is 65, so that means that DC must also be 65. So they actually told us more information than we needed for this problem. So the converse of the perpendicular bisector theorem, remember a converse is where you switch the hypothesis and conclusion of an if-then statement. So now it says, if a point is equidistant from the endpoints of a segment, then it lies on the perpendicular bisector. So this is stating if we know that these two segments are equal, meaning congruent, which I'm showing with the little dashes, then we can conclude that this must be a perpendicular bisector. So before we said it's a perpendicular bisector, these are congruent. Now we're saying these are congruent, so it's a perpendicular bisector. So let's look at example 2 right here. And I'm going to mark up the figure as we go through it. So here they tell us that PA is congruent to PC. BA is congruent to BC, so I'm going to do double dashes here. Use the diagram below to find the angle measure described. So they say, suppose angle 2 is 23 degrees, find angle 1. So we can say, since PA is congruent to PC, meaning this point is equidistant to these two, we know that PB is a perpendicular, that's the symbol for perpendicular, bisector of AC. So again, since these are congruent, we know that PB is a perpendicular bisector. Since it's a perpendicular bisector, we can make the statement that angle 1 plus angle 2 must equal 90 degrees, because that's what perpendicular means. And now we can substitute what we know about angle 2, which is that it's 23 degrees. So equals 90. So that means angle 1 must be 67 degrees. So again, we have to make sure we can state how we know that this is a perpendicular line, and it's because PB is a perpendicular bisector. Again, we know that because these two segments are congruent. Okay, so now we're going to do just a little bit of mixed review that involves still perpendicular lines. So in this one, they say B is parallel to D, so line B is parallel to D. I'm going to add that in. I'll do a red, showing they're parallel. And C is parallel to E, so I know these are parallel. I'll do double carets there. They know that angle 1 is 47, angle 5 is 90, meaning perpendicular. and they would like us to use the diagram to find angle 4. So we want to see if we can work our way over here. So the first thing that I can do is, well, we can look for two parallel lines cut by this transversal, and we can say that angle 1 is congruent to angle 2 because they are corresponding angles. So that means that angle 2, the measure of angle 2, is also 47 degrees. So if angle 2 is 47 degrees, I know that the measure of angle 3 is also 47 degrees because they are vertical angles. And then since we know that this is a 90-degree angle, angle 5 is 90 degrees, we can also state that angle 4 plus angle 3 must equal 90, right? Because they're on a straight line, which adds up to 180. So if this is 90, the other side must be 90. And we know that angle 3 is 47. So angle 4 plus 47, I'm substituting now, equals 90 degrees. So angle 4 must equal 43 degrees. There you go. All right, this next one says, two lines intersect to form a linear pair with equal measures. So if you think about this, the only way to make a linear pair, which means they add up to 180 with equal measures, is if they are both 90 degrees. So it says one angle has a measure of 2x and the other has a measure of 6y minus 24. Find x and y. So we know that they're each equal to 90. So I'm going to set up my first equation, and I get x equals 45. Then I can say 6y minus 24 equals 90. So 6y equals 114. And then I'm going to divide both sides by 6, and I get y equals 19. So again, you do have to realize that the only way to have a linear pair with two equal measures is that they are both 90 degrees. This last one says, use the diagram shown. BD is the perpendicular bisector of AC. So not only is it a 90-degree angle, but we know that these are also congruent. And since it's a perpendicular bisector, they've already drawn this in. We know that these are congruent. It says AD is 51 inches. BD is 24 inches. Find the length of AC. So I'm looking here and I say, well, I may not be able to find the length of AC, but if I look at a smaller portion, if I look at just one part of my triangle, I see that I have a 90-degree angle, which means this is a right triangle. So I can use the Pythagorean Theorem, which is a squared plus b squared equals c squared. So remember, the only one that needs a specific value is the hypotenuse, which is 51, so this must be our C value. So we can say 24 squared plus x squared, I'll call this x, equals 51 squared. So I'm going to do 51 squared minus 24 squared. And I get x squared equals 2025. So now I'm going to take the square root of that number, and we get x equals 45. So now that I know that x equals 45, let's look back at what they're asking us to find. They want the length of AC. So if that side's x, I can call this x. So we can say x plus x equals the length of AC. 2x equals AC, and now we can substitute what we know for x. So that means that AC has a length of 90. All right, that is all for today's lesson. Thank you for watching.